Welcome to Unit 2. This is Unit 2 of ABMA Computing and Information Systems Diploma Level 4. Unit 2 is computer programming. So we are going to talk about computer programming. And the first outcome in this unit is that we should be able to evaluate the common programming languages. That means we need to know what a computer program is, why do we need computer programs, and then what are the programming languages that are actually in existence, what are the various types. So let's get started, guys. Okay, let's get started. Just a moment, just want to set a few things up here. We get started. Alright, so we have to understand the meaning of computer programming. But even before we understand the meaning of computer programming, it is of essence for us to understand what a computer program is. Okay. Now, one thing that we need to understand is that computers do not understand the natural language of humans. Computers do not understand English, they don't understand Spanish, Germany, they don't understand Italian, they don't understand French, they don't understand the language of humans. But again, we still need to communicate to computers because we use them in day-to-day activities, so we need to tell them what to do for us so that they are able to do what we want them to do. Again, think of it. It is easy for a human being to learn a language, a new language, than actually having a computer learn the natural language. As in, how are you even going to train it to learn that natural language if you cannot communicate to it in the first place? So when we talk of a computer program, we are basically talking about a set of instructions that are performing a certain task when they are run by a computer. So a computer program is a set of instructions that perform a task when they are executed by a computer. Now, most of the computing devices we know, they would require programs to actually have them function properly. They would require programs to have them function properly. I will talk about what I mean by execution. First things first, let's understand what a computer program is. So we said a collection of instructions that we when a computer executes them, then they do a certain task. The people who write computer programs are known as programmers. The people who write computer programs are known as programmers, and they use a language, or they use languages called programming languages. Okay, they use languages known as programming languages. Now, we are writing our programs from a human readable form. So when we write code, we are writing it in a human readable form using a computer programming language. And this code that programmers write, we normally refer to them as source code. We refer to the code that programmers write as source code. We normally refer to them as source code. Of essence, you will understand that these source code are actually instructions that the computer, the human is able to read. The source code are the instructions that we write in human mind, in human language, that the computer is able to read. Now, that a human is, no, let me put this thing straight. The code that programmers write is known as source code, and this code is written in a human readable language, so a human can actually read it. This code is known as source code, but computers do not understand human language. They don't understand these high-level programming languages. I'll talk about them. Programming languages, they understand machine code. So that means when we write programs in the human readable format, they are supposed to be converted into machine code. That is the process. We call it compilation. They have to be compiled either using a compiler or using an assembler, so that now what we get from the human readable code is machine code. Machine code is simply the set of instructions that a computer can directly understand and actually execute them. The set of instructions that a computer can directly understand and execute them is what we call source code. That is what we call source code. Okay, let's go on. Now, instead of having a compiler compiling our source code or the human readable code into machine code, we can have a program being executed with the aid of an interpreter. Okay, I will come back to that later. Now, when we have so many computer programs or a collection of computer programs, we have libraries and we have data that is actually working together, then we call that collection a software. We call that collection a software. So in layman's language, I can define a software as a collection of computer programs, libraries, and related data. Now we categorize computer programs based on their functional lines. For example, we have application softwares and we have system softwares. Now, application softwares are basically programs or softwares that are written to perform a specific task. For instance, if we talk about Adobe Photoshop. Adobe Photoshop was written and was created purposely for editing pictures. Now, does it mean we don't have other softwares that can do some simple edits? Even Microsoft Word can do some simple transformations and edits on pictures. But when it comes to editing pictures, Microsoft Word is not the best option. Why? Because Microsoft Word was not made for pictures. That is not the specific a function it was made to do. So when we want to edit pictures, we would run to Adobe Photoshop. Why? Because it was made purposely to edit pictures. So the softwares or computer programs that were made to perform a specific functions, we call those softwares application softwares. Then we have other softwares that we call system softwares. These system softwares are actually softwares that they help systems to run. For example, the operating system like the Windows, the Mac OS, all these are softwares that without them the computer system cannot work. Also the Android, so we call them a system software. Also the BIOS system, basic input output system, is an example of a system software. Now we also have to know what computer programming is then. So we define computer programming as the process of designing and building an executable computer program to accomplish a specific computing result. The entire process that is involved starting from you designing the interfaces, creating the interfaces, and going to the implementation stage, where now you are writing code to actually implement or convert the design into a real stuff. Yeah, and that entire process is actually directed into creating a program that is going to solve a specific purpose. We call that computer programming. The entire process: designing, building executable computer programs that are able to accomplish specific results or specific tasks. So when we're talking about programming, we are talking about tasks. For example, you can have a software that does analysis, you can have a software that is generating algorithms, we can have software that is profiling algorithms, we can talk about accuracy, resource consumption, we talk about even implementing those algorithms. So when we're talking about computer programming, basically we have processes that we need to follow. First, we need to look at the software we are building here. What are the requirements of this software? What are the requirements of this software? Then after knowing what are the requirements of this software, basically we are going to move another step ahead into analyzing those requirements, making sure they are clear. Then we move into another step now of creating a proposed design. We generate algorithms that we're going to follow. All those steps up to now, choosing now the programming language that we want to use. Then we write now code. Now it is important to understand that I said the code that programmers write that is human readable is known as source code. So it's important to understand that the source code of a program is written in one, it can be in one or even many programming languages. But these languages are actually known by programmers. They are intelligible to programmers. Okay. Now, I said the source code is then converted to machine code that is now executed directly by the CPU, or the central processing unit. That's enough intro for what programming is, what are programmers, and what is a computer program. Let's talk about the common programming languages. Now, what is a language? Basically, a language is a medium of communication. It is through a language that we are able to share ideas, we are able to share opinions to each other. It's through languages that we are able to communicate. Whenever you want to communicate to someone, then you basically need a language. You need a language. So regardless of what language you're going to use, you might be using English, Spanish, German, Hindu, or any other language. But regardless of the language you're using, you need to have a language to communicate. Now it is the same way with computers. You want to communicate to a computer, understand a language. You need a language to communicate to a computer. For you to be able to communicate to a computer, just as you need a language to communicate to humans, you also need a language to communicate to computers. Okay. So if you do not have any programming language, then you will not be able to communicate to computers. So what is a programming language then? A programming language is the medium of communication between a person, and this person is a programmer, you in this case, and a computer system. That medium of communication that you will use to give instructions to a computer is what we call computer programming. So it is basically a collection of instructions that you are writing in a specific coding style to give a computer an instruction to maybe do a task. We have various types of computer programming languages. There are three. I'll talk about three of them. And the first one is the low-level programming languages. We have the high-level programming languages, and we have the middle level programming languages. So let's begin with the low level programming languages. Now, when we are talking about low level programming languages, we are talking about a language that is machine dependent. What do I mean by machine dependent? I mean it is a language that is close or is close to the machine language. Examples of these languages: we have the machine code, we call binary. Then we also have the assembly language. Now, what you need to understand is that the computer understands binary language. So, what is binary language? Binary language is a language that is made up of its instructions are made up of series of zeros and ones. Okay, we either have high signals or low signals, on or off. So their programming languages are the low-level programming languages are languages that can give signals in the best way to the computer directly. Why? Because the computer is able to understand that language directly. So they don't need to be compiled. They don't need to be converted into some other form of a code. So we're talking about machine code. We are actually talking about binary language. So we don't need any interpreter. We don't need any compiler to convert this particular language in any form. Why? Because the computer is able to understand the signals of this language directly. So for the machine language, as much as it is a low-level programming language, we don't need any compiler because it's the language that the computer understands. But when it comes to the other example, which is the assembly language, now this assembly language needs to be converted into a binary code for the computer to understand. Okay, so you write instructions in assembly language, then an assembler is used to actually convert the code we have written. That assembly code, it is going to be converted to an equivalent binary code. So whatever meaning that we were actually trying to communicate in assembly language will be the same meaning that it will be communicated in that binary code. So let's understand. We said low-level programming languages are programming languages that the machines the computer can directly understand them. And I have given two examples. I've spoken about the binary language, which is the machine language, and it is the language the computers can understand. And we said for the binary language or the machine language, it does not need to be compiled. You don't need a compiler or an assembler to actually convert that, because it's like you're speaking English and I understand English. We don't need an interpreter. We don't need an interpreter to actually interpret that. But now the assembly language is somehow closer to machine language, but it's not directly as machine language. So we need an assembler. We write code in machine language, then we need an assembler that is going to actually convert that code that we have written in assembly language to an equivalent code that is in binary form. Now, one pitfall or one downfall or one disadvantage that is of great essence to these languages is that writing code or writing a program using the low-level programming languages is very difficult. It's difficult to write, it's difficult to read, it's difficult to edit, it's difficult to understand. That is one. It is difficult to write code in low-level programming languages. It's like now converting all the instructions into series of zeros and ones. Very difficult. Then it is also difficult to edit that code. It is difficult to understand that code. Reading the code is also difficult. The disadvantage number 2 is that programs that are written in this particular language they are not portable. They are not portable. So that means if you write that language for a particular system, it will be used by that system. only. If you move it to another system, it can't. You need to now write code for the other system also. Now, who would really want to live in that messed environment where every time you want to use a machine, you have to write a similar code that you wrote in another machine so that you have it running in this machine? If we have a language that can run across platforms, I don't think our problems are solved. Yes, definitely, our problems are solved. Those two disadvantages now make makes programmers and made people to come up with other types of languages that are not really difficult to understand, to read, and to edit. So, as much as we've seen those two greater limitations of low-level programming languages, it has its own strength. And the first of the strengths, something I've already mentioned. If you write programs in these languages, the programs are going to be executed very fast. The execution is going to be faster if we compare them with the other programming languages, the middle level and the high level. The reason is because we don't need a lot of translation, a lot of compilation here. Okay. The advantage number 2 is that these programs will most definitely have less words. They will have less symbols. Okay, and we don't need to convert them. So we need to get that programs that are written in low-level languages are executing very fast, because we don't need to interpret. We don't need to waste some time converting them. They also have less keywords, less symbols, and that is advantageous. Let's move to the high-level programming languages. So the high-level programming languages are machine-independent programming languages. They are machine-independent. They are easy to write. They are easy to read. They are easy to edit. They are easy to understand. So that means you can write a program in this particular system, and then that same program can run in other systems as well. So examples of the high-level programming languages: we have the .NET, we have Pascal, COBOL, we have C++, C#, C. Yes, we have so many others. So when we are actually talking about the high-level programming languages, we are talking about languages that have keywords. So we can talk about they have some special keywords. The languages that have some special keywords. They have keywords, they have functions, they have what we call class libraries. So we can use all these to build a program for a computer to understand. However, the computer is not able to understand these languages directly. So just like I said before, we need to convert this language. We need to actually translate this language into an equivalent machine code. So we write in a high-level programming language, then we have the compiler that compiles our source code into machine language, a language that the computer can understand. The result of that is, if you compare the high-level programming languages with the low-level programming languages, then definitely they are gonna be slow, because we need to waste some time there to convert those instructions. So we use translators. For example, we have compilers and interpreters that are actually system softwares, and we use them to convert that program from a high-level language to a machine language where the computer is able to understand directly. Now let's look at the features of high-level programming languages. Now the first feature that I'm going to talk about is that they are independent. They are independent. I've mentioned this earlier. Now what it means by independent is that you can write a program on a system and then have that program run in another system. You don't have to write a new program each time you want to have another system, you want to work with another system. So you can simply carry that program from one system and use it in another system. Number 2, they are definitely easy to understand. They are definitely easy to understand. These programs are easy to understand. Now, why are they easy to understand? Because we have keywords, we have functions, we have class libraries. Now, the keywords, the functions, the class libraries are words that are similar to English. So we are able to understand the meaning of these keywords and those terms that are actually related in that particular program. For example, if I'm using Python and I'm going to print some text, I simply say print, then into bracket, put my quotation marks, and say hello world. It is as easy as that. So you can read the word print. Now imagine now writing the word print in a machine language in series of zeros and ones. You can imagine how hectic that can be. So they are easy to understand because we have keywords, we have functions, we have class libraries that have words that are actually similar to the English words, and they carry meaning that the meaning is also similar to the English words. Feature number 3 is that the code written in high-level languages is easy. Writing that code is easy, reading the code is easy, and editing the code is easy as well. So it is easy to write, it is easy to edit, and it is easy to understand the code. Okay, now because it is easy to understand, to read, and to edit, that means you can write code in a programming language, and another programmer can come and read your code and edit your code and change how your code functions. Why? Because the programmer is able to understand your code. So that means a programmer can edit another programmer's code. Okay, and you don't need to be an expert in that programming language for you to do some changes in another person's code. You just need to have some basics. Now, as much as the high-level programming languages we said are slower than the machine or the low-level programming languages, they are the most popular programming languages that are used to develop user-end applications. So that would mean that many programmers we have, majority, if not all of them, are coding using high-level programming languages. Let's go to the middle-level programming languages. Now, if you go and search through different resources in the internet and even read books, you might not come across a type of a programming language known as middle-level programming language. But why do we call them middle-level programming language? We call them middle-level programming language because they combine both the features of low-level programming languages and those features of high-level programming languages. So we have languages that actually they combine the features of the two categories of programming languages, and I decided to call them middle-level programming languages. So those languages that have the features of low-level programming languages and the high-level programming languages, now we refer to them as middle-level. We refer to them as middle-level programming languages. And a good example of that of the middle level programming languages is the C programming language. The C programming language has both the features of the low level programming languages and the high level programming languages. Yeah, those are the three categories of programming languages. Their advantages, their disadvantages. So let's move on and talk about the historic development and updating of the common programming languages. So we're going to go back to dive back in 1822, where Charles Babbage brought in the difference engine. So when the difference engine came in, invented by Charles Babbage, computers that at that time they needed a way, or rather human beings needed a way to actually give instructions to computers to enable the computer to perform some tasks. Now this means, or this way of enabling these computers or these human beings to communicate to computers, giving them some instructions to do some tasks, is what we call programming language. So previously in history, we had computer languages that were composed of a series of steps that were being followed in writing a particular program. So we had a series of steps keyed into the computer, then they are executed. So from there we moved on. We had more advanced features. For example, the logic branching came in, object orientation came in. So when we look at computer languages now for the last 50 years, then we are talking of two major stages in terms of computer programming. So we'll be talking about, we are looking at the first major languages, and we have the second major languages that are actually used today. But we first had a series of instructions. Then later, like 50 years later now, the logical branching was introduced. So looking back 50 years ago, we have two stages, or we have two stages, or we can say the languages are coming in two stages. We have the major languages, and we have the first major languages, and we have the second major languages that are actually being used today. So when we look at the Charles Babbage's difference engine, in the beginning, this particular engine could only do tasks by changing gears, and then if we change those gears, then some calculations are done. So that means now this was the first language to talk to computers, and that language, we call it physical motion. That is the first computer, or the first form, or the earliest form of computer languages. We call it physical motion. So we have physical motion, physical motion, physical motion, and later now we are replacing physical motion by electrical signals. Now this happened in the year 1942. That is when the United States government built what we call the ENIAC. Now if you look at the ENIAC that was built in 1942 by the US government, it was working through or following the principles of Babbage's engine. Yeah. So again, same issues. So the ENIAC could only be programmed by we are just presetting some switches there, rewiring the entire system. For every new program we want to run, we have to preset some switches. We have to rewrite the entire system. or maybe the entire calculation. Now again, you can imagine how that is. That is very tedious, very tiresome, cumbersome. Call it. Describe it in whichever way you can. But you can imagine every time you want to do something, you have to write the same instructions you wrote. You have to rewire to do rewiring again. That's really tiresome. So that's why now we have John von Neumann that came in with two very important concepts that nobody thought they are going to affect the path of computer programming. That was in year 1945. John Neumann was working at an institute for advanced study. So he came up with two concepts that affected the path of computer programming languages directly. And the first one was known as shared program technique. You can find more information about that in www.softload.com. Now if you look at the shared program technique, actually it is a technique that stated that the actual computer hardware should be simple and not need to be hand wired for each program. In other words, this guy was trying to say, you know what guys, I'm tired. I do not want to keep on wiring things every time I want to have another program run. I don't want to do that. So we should think of coming up with a hardware, computer hardware, that does not require any hand wired for each program that is gonna run in that computer. So he said, now instead of having having us to hand wire every program, then we need to have some complex instructions that are going to control that simple hardware. We have instructions that are complex, but at the same time these instructions are serving a very important role because they are able to actually control that simple hardware that does not require to be hand wired each time we want to run a program, to actually allow that hardware to be reprogrammed much faster. That was the first concept. We need a simple hardware that does not need to be hand wired each time we want to run a program. So instead of that, we're gonna have some complex instructions that will control that hardware to have it being reprogrammed faster. So that was the first concept by John von Neumann. He called that concept shared program technique. The second concept that was actually the most important in the development of programming languages was given the name conditional control transfer, still by John. You can still get that, read more about it in www.softload.com. Now the conditional control transfer now led into the rise of subroutines, or we talk of gave into the rise of small blocks of code. Small blocks of code that did not require execution in a specific order. Small blocks of code that you can just jump around from one block of code to another without following any specific order. So we did not have any chronological order here. You can skip from block 1, jump to block 5, execute block 5, go back to block 3, execute block 3, then go to block 10, execute block 10, and come back to block 2. So you can skip from one block of code to another regardless of what order of execution is actually put in place. Isn't that interesting? Very interesting. So we do not have a single set of chronologically ordered steps here that the computer should follow. That is actually the first part of the idea. Now the second part of that idea was that when we have the computer code, then we should be able to branch that computer code based on on some logical statements like the if expression. Then, for example, we want to see if you are eligible to drive in Kenya. Now, in Kenya, we drive from the ages of 18 years and above. You become a grown-up, 18 years and above. So we want to check if you can drive or you can't drive. So we should be able to actually branch based on logic, some logical statements, like for example the if statement or the if expression. So we say if age is greater than or equal to 18, then dear brother, dear sister, you can drive. Else simply means your age is below 18, you cannot drive. No, you begin to see that programming is now getting more interesting. Yeah, because now we can create a mind for the computer. We can create a logic for our program. So after us having the logical statements like the if expressions, then we can have a loop. We can loop such statements with maybe a for statement, conditional control transfer. And that brought in the ideas of libraries. What are libraries? Blocks of code that can be reused over and over. Reusability came in hand. In other words, you just write a block of code, and that block of code, you can use it 10 years to come. You can give, another person can still use them. You use it in any other program you wanna use it. Reusability has come in. Now you do not have to write code for every specific machine again. Number two, you do not have to rewrite the same code, to rewire again. You don't have to follow chronological order. You can jump around. It's amazing. Today, we programmers really are enjoying. We have so many libraries built by other people that we use them. We just use them, and we'll keep using them. We're gonna use them, and when we think we need to write our own libraries, we're gonna put them there. You upcoming programmers can still go in and use. So the library is a blocks of code that can be reused over and over. They don't get to a point and say, hey buddy, we are exhausted, we cannot continue working. No, it can be reused over and over. Now, few years later, we have von Neumann, who has brought a really big transition, a really big difference in the development of programming languages. But now, few years later, we had something known as the language shortcode. That came in 1949. That is few years after we have enjoyed von Neumann's work. Now, the language shortcode actually was the very first programming language for electronic devices. It was the very first programming language for electronic devices. Now, one funny thing is that this language required to have the programmer changing the statements into series of zeros and ones by hand. Yeah? As much as it's still difficult, that is a step. We've taken a step towards having the complex languages that we have today. So, after that idea, we have Grasshopper coming in, and the Grasshopper, in the year 1951, she came in and wrote a compiler. We have the first compiler. Read that from www.byte.com. She wrote the first compiler. Now we've talked about a compiler before. I've said a compiler is simply a program that converts your source code, your human readable code, into series of zeros and ones, or into machine code, a language that computers are able to understand. That is a compiler. Okay. Now this brought the revolution and the speed in terms of advancements, in terms of the speed now, in terms of the growth of programming languages. Why is it becoming faster? Now we do not have to convert our statements again from zeros to from our language to zeros and ones by hand, because we have a compiler that is doing that work for us. In 1957, now we had the first major programming language, or we can say the father of the major programming languages, is now appeared in, and that programming language appeared in a form that was known as Fortran. Fortran stands for Formula Translating System. Formula Translating System. Fortran was designed at IBM, and the reason as to why IBM designed Fortran is because they wanted to use Fortran for some scientific computing. So it is a language that had very simple components that actually gave the programmer some low-level access to the computer innards. Now, if we look at this language today, we're gonna say this language is it is restricting me. It is preventing me from moving. Why? It only had the if, do, go to statements. If this, do this. From here, go to this. For now, you might overlook it, but at that period of time, these commands were really a big move. They were really a big move. It is from this language that we are actually enjoying the basic types of data that we are using today. We have logical variables, for example, the Boolean variable, true or false. We have the integers, the real, the double, precision numbers, and all that. All that originated from here. They are moved from the Fortran. Without the Fortran, we wouldn't have those variables. Now, as much as Fortran was a greater move, it was very good when it comes to handling numbers, it had a downfall, it had a disadvantage. And the disadvantage is that this particular programming language was not very good when it comes to handling input and output. It is not good when it comes to handling input and output. But again, the input and output is what is actually, that was the most important aspect when it came to business computing. So in 1959, business computing took off. And because we are having business computing kicking off, COBOL was developed. COBOL is actually a very interesting language, designed purposely or for the ground, for business. Was designed for businessmen. It was a language for businessmen. So because it was a language for businessmen, it only had two types of data types, and that is, it had the numbers and strings of text. But again, I think it also introduced the third data type, because you could group these numbers and strings together into an array. Arrays are very useful. You learn about arrays. They are very useful. Now, because you are able to group the numbers and strings into arrays and records, then it was possible to actually track data. It was possible to actually have better organized data. Now, the Kobo language is built similar to an essay. It has 5 major sections. 5 major sections. And it has also an English-like grammar. So that made it quite easy to learn Kobo. Now, why should we have a language that looks like an essay with 5 sections? It has its syntax is very close to the English grammar. We are still trying to make it easy for the programmer. We want that starting business, that average business, to be able to learn the language and put itself up and running the language. We kick on to John M.C. Carthy of MIT, who created the list processing language, LISP, in the year 1958. Now, the reason as to why we had the LISP is because we were going into artificial intelligence research. So it was built purposely for the artificial intelligence research. Now, this particular release had some unique syntax. So we had programmers writing code in parse trees. I'm going to talk about parse trees much later. But it was a compiler-generated intermediary between that syntax and the lower level code. So if you look at this particular program, there was an obvious difference. Yeah. And the difference is because is this. If you look at the LISP in its original form, it had a basic and an only data type, or an only type of data, and that was the list. But in the year 1960, 2 years later, the LISP acquired other types of data. I'll talk about the list much later. The LISP is still in use even today. Still in use even today. I'm just taking you through a short history. It might be long, but to me it's short. So in the same 1958, we had another language called the Algol language that was created by a committee for scientific research. It had a major contribution because it became actually the root tree that led into the development of languages like Pascal, C, C++, and Java. And again, guess what? This is the very first programming language that is coming in with formal grammar. And the formal grammar was known as Backus-Naur form, or what we call the BNF. It implemented some novel concepts. For example, we have recursive calling. So functions could be called recursively. Now then, the other version that came in was Algol 68. Now Algol 68 became bloated. It became difficult to use. Now when it became difficult to use, now people, programmers are looking for simple things. So people had to adopt languages that were actually smaller, and they were even compact. They were compactable. So programmers adopted languages like Pascal. Pascal. Is it Pascal or Pascal? Whatever. Now, Pascal originated or was begun by Nicholas With in the year 1968. And the reason as to why this program came into development is because there was necessity for a good teaching tool. The other language was becoming confusing and difficult. So at the initial stages, we had the language designers that they really did not have the hopes for of Pascal to enjoy widespread adoption. They did not expect that the world would really take it in. But again, they were just focusing on just developing some good tools for teaching. For example, a tool like the debugger, an editing system, yeah, just tools that would be used for teaching and even support some early microprocessor machines that were being used in those teaching institutions. So because it was designed purposely for teaching, guess what? Designed in a very orderly manner, in a very orderly approach. It had many of the best features of the languages in use at that particular time. The Kobo, it has the features of the Kobo, it has the features of Fortran, it has the features of Algol. So because it had combined so many features, then many oddball statements were cleaned up, and then it began to gain users. Oh, so if we look at the things that it brought, it improved on something known as the pointer data type. The pointer data type is very useful. We're gonna look at that. Then it brought into the led us into the introduction of case statements. Now, in a case statement, instructions are allowed to branch just like in a tree manner. So we have the case expression of possible expression value 1, statements to execute, possible expression value 2, statements to execute, and then we are ending there. So Pascal also contributed in the development of dynamic variables. Okay, that's enough for Pascal. In 1972, Dennis Ritchie, he was working at Bell Labs in New Jersey. So he developed the C programming language. So we are now transiting from the first major languages to the major languages of today. So is occurring here. That transition is occurring here. The transition from first major languages to the major languages of today. It is that great move. I don't know how we're gonna call it, but it is that great move. Like the Pascal, moving from Pascal to C. A great transition, a great move. So if you look at the C programming language, one funny thing, you realize that all the features that were actually available in the Pascal programming languages, including the case that was actually introduced later, they are available in C. Pointers are used extensively in C. Yeah. Now, the C programming language was majorly using pointers. It was built to make sure that we have a fast language, we have a powerful language. But now people had to sacrifice the aspect of having it as a hard language to read. So it was very hard to read that language. But because the C could actually fix most of the mistakes that were in Pascal, then it took it over. We have Pascal users quitting from Pascal rapidly, now adopting C. Now we have Ritchie again developing the new Unix system. So he developed the C programming language for the new Unix system. So if you look at Unix and C, you will see they have things that look similar. In late 1970s and early 1980s, we had another great move by having a new method, a new programming method that was developed, and that method is known as OOP, the object-oriented programming method. So it is a method that focuses on objects. Now, what are objects? Objects, they are just pieces of data that can be packed and manipulated by the programmer. Now, we had another great guy, Bijane, who was really interested in this particular method, and he went ahead and developed some extensions to the C programming languages and called it C with classes. And then that C with classes developed into what we call the C++ language that was released in 1983. In the early 1990s, we had what we call interactive TV as a technology that was really focusing in a future. A technology that was portable. By portable, it means we can have that technology run in so many other machines and languages. Now, guess what? The iterative TV is what now became the present Java language. So in the year 1994, we had the Java project team that changed the focus to the web, because now the web at that time was booming. It was becoming a cool thing. So when we have a iterative TV failing, the year that followed, then we had Netscape that licensed Java to be used in their internet. So we have now Netscape using Java. A year later, Java is used in their internet browser and navigators. So at this particular time, we are having Java programming language becoming the language of the future. We have so many companies that are announcing applications that needs to be written in Java. Yeah, but again, none of those applications were never used. That will shock you. Now, Java became the textbook of a good programming, or a good example of a good language. It has some serious optimization problems. The programs that were written in Java, they were running very slowly. Yeah, they were running very slowly, very slowly or very slow. I don't know. Not very good in English. Okay, let's forget about Java, because now another programming language hit in the year 1964. That language is known as Visual Basic. Now, if you look at you look at courses, programming courses in colleges and universities, Visual Basic is often taught as the first programming language. Now, the reason is because it is based on the basic language that was developed by John Kemeny and Thomas Kutz. The Visual Basic, though it was a very limited language, and it was designed for actually people that are not computer science oriented. Visual Basic. So we had Microsoft extending the Visual Basic into its Visual Basic VB product. So now it's a product of Microsoft. So when you look at VB, Visual Basic, actually its heart is on a blank window. You have a blank window, then you are dragging and dropping components. For example, menu pictures, slide bars, you have input boxes, you have buttons, you are dropping them there. So the items that you drag and drop there are known as widgets. So the widgets had properties like you could change the color, you could have some events. You can handle some events like clicks, double clicks, on key press, on mouse move. And these were actually very useful when it comes to building user interfaces, even today in any programming language. Now, if you look at VB today, we often use VB to actually create some simple and some quick and simple interfaces to some other Microsoft products. For example, Excel, Access, because it does not need a lot of coding. But again, it's powerful because it's very possible for you to create a full application from VB.NET, from Visual Basic. In 1987, we had Perl, developed by Larry Wall. And since then, we have had programming languages under development. They have been under development, improving every day, every year, every time. Yeah, that's just a brief history. Now, I want us to talk about the last thing in this lesson. That is the key strengths and weaknesses of interpreted and compiled languages. I want to take you back to the introduction of this class where I told you we write code in we write our source code in a human readable language, then that code is converted to machine code, either through compilation or interpretation. So we have languages that are interpreted and we have languages that are compiled. So I want us to look at what are the strengths of interpreted languages, what are the strengths of compiled languages, what are the weaknesses of interpreted languages, what are the weaknesses of compiled languages. So we need to start from there. What is a compiled language? Now, a compiled language is a language that gives us a program that once you compile it, that program is expressed in the instructions of the target machine, that specific machine you're creating the program for. So you have machine code that is undecipherable by humans. Human beings cannot look at that machine code and understand what is really happening. An interpreted language, on the other hand, is a language that gives us instructions that are not directly executed by the target machine. Instead, we have these instructions being read and then being executed by other programs. So they are not actually being executed directly by the target machine. So if you look at the compilation and the interpretation, both of them, they have benefits and they have their own disadvantages, they have their own pitfalls. Now that's the main reason we're gonna look about them. We're gonna talk about them. Compiled languages. Now there's one major advantage when we're talking about compiled languages that is actually an edge over the interpreted languages, and it is the execution speed. That is the major advantage for compiled languages, the execution speed. Now because we are converting these languages directly into machine code, then they are going to run significantly faster, they are going to be more efficient, okay, than when we compare them to the interpreted languages. For instance, if we consider the complexity of statements, maybe in some of the more modern scripting languages that are interpreted. So we have low-level languages that tend to be compiled. And the reason they tend to be compiled is because we have a major and a greater concern in terms of efficiency. The other reason could be compiled languages are converted directly into machine code. Now this is going to give you as the developer some much more control over the hardware aspect. For example, you have the management and the CPU usage. So if you look at the examples of pure compiled languages, we have languages like the C, we have the C++, we have the Erlang, we have the Haskell, and more modern languages. We also have the Rust and Go. So despite the compiled languages giving us a high speed of execution, more accuracy, and giving us control of CPU and storage. What are the disadvantages? Now, you need to understand one thing. For you to actually run a program that is written in a compiled language, you need to manually compile that program. Not only manually compiling it, you need to debug the program. Need to check for errors. After checking for errors, you recompile that program again. So each time you want to test the new changes you have made in that code, you have to recompile again. Now that would mean you write some code, you check it for errors, you compile it. You notice some errors, you come and make some changes, you recompile it. You come make changes, you always recompiling. Now it is going to make debugging very tiresome. That is one of the reasons, one of the disadvantages. Another disadvantage is that compiled languages are not they are not platform independent, because the code that is actually compiled is going to be specific to that particular machine that is executing it. Those are two. Let's move to the interpreted languages. We are contrasting it with the compiled languages. So interpreted languages, they do not require machine code in order for them to actually execute the program. I've talked about this previously. We have interpreters here that are going to run through the program. They're going to look at the program line by line, execute each command line by line. Now, previously, this became a disadvantage, since when you compare it with the compiled language, because there was a lot of time that needed to be taken to actually execute programs. But we have new technologies. For example, we have the just-in-time compilation. We that gap, that difference is narrowing down. Okay, it's not yet boom. It's still somewhere. Okay, it was here. Now it is, because we have technologies that are actually working in time. So you have some interpreted languages examples. For example, you have the PHP, preprocessor language. We have the Perl. We have Ruby. We have Python. Now, we have programming concepts that actually make these interpreted languages easier. And the first one is platform independence. They don't depend on a platform. There's reflection. There's dynamic typing. Then when you write programs in these languages, you get small executable programs. The programs have a dynamic scope. But again, the main disadvantages of this programming language is that they are very slow. They are slow. They have slower program execution speed when you compare them to the compiled languages. Again, remember we talked about the just-in-time compilation that is actually now helping to convert the executed sequences of interpreted instructions into host machine frequently. So for today's class, I wanna stop there. Till next time, I'll meet you. We'll talk about the key strengths and weaknesses of imperative, object-oriented, and functional languages.